Welcome to our video on the top 20 core Java coding questions you might find useful for interviews or practice, whether you're a beginner or brushing up on your skills. These questions will test your knowledge and problem-solving abilities. We'll cover a wide range of topics from basic string manipulation to more advanced algorithms and data structures. Each question will be explained in detail, with clear and concise code examples to help you understand the solutions. Let's dive into these essential coding problems and their solutions. Our first problem is determining if a string is a palindrome. A palindrome is a word or phrase that reads the same backward as forward, like race car or madam. How can we check this programmatically? We'll start by comparing the characters at the beginning and end of the string. If they match, we move inward, comparing the next pair of characters. We continue this process until we reach the middle of the string. If all the characters match, we know the string is a palindrome. If we encounter even a single mismatch, we can immediately conclude that the string is not a palindrome. We'll walk through a Java code example to solidify this concept. The Fibonacci sequence is a famous mathematical series where each number is the sum of the two preceding ones. It starts with 0 and 1, and the sequence continues as 0, 1, 1, 2, 3, 5, 8, and so on. To generate this series in Java, we can use a loop that iterates up to the desired number of terms. We'll need two variables to store the two preceding numbers, initialized with 0 and 1. In each iteration, we calculate the next Fibonacci number by adding the previous two and update our variables accordingly. We'll print each Fibonacci number within the loop to display the series. The factorial of a non-negative integer, denoted by n factorial, is the product of all positive integers less than or equal to n. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which equals 120. In Java, we can calculate the factorial iteratively using a loop. We'll initialize a variable to 1 to store the factorial value, then we'll loop from 1 to n, multiplying the current factorial value by the loop counter in each iteration. This process ensures that we multiply all the numbers from 1 to n to get the final factorial result. We'll illustrate this with a Java code example. A prime number is a natural number greater than 1 that has exactly two distinct positive divisors, 1 and itself. The first few prime numbers are 2, 3, 5, 7, 11, and so on. To check if a number is prime, we can iterate from 2 to the square root of the given number. In each iteration, we check if the number is divisible by the current loop counter. If we find any divisors, we know the number is not prime. If the loop completes without finding any divisors, the number is prime. This method optimizes the process as we only need to check divisors up to the square root. Let's look at the Java code for this. Reversing a string is a common programming task. We can achieve this in Java by treating the string as an array of characters and iterating through it in reverse order. We'll start by creating an empty string to store the reverse string. Then we'll loop through the original string from the last character to the first. In each iteration, we append the current character to the reversed string. After the loop completes, the reverse string will contain the original string in reverse order. A code example will clarify this process. Finding the largest and smallest numbers in an array is a classic programming problem. We can solve this efficiently by iterating through the array only once. We'll initialize two variables, one for the largest and one for the smallest, with the first element of the array. Then we'll loop through the rest of the array, comparing each element with the current largest and smallest values. If an element is larger than the current largest, we update the largest. Similarly, if an element is smaller than the current smallest, we update the smallest. After the loop, our variables will hold the largest and smallest numbers in the array. We'll demonstrate this with a Java code example. Removing duplicate elements from an array is a common task in programming. One approach is to use a temporary array to store the unique elements. We'll iterate through the original array and check if each element is already present in the temporary array. If an element is not present, we add it to the temporary array. After processing all elements, the temporary array will contain only the unique elements from the original array. We can then copy the unique elements back to the original array or create a new array with the unique elements. Finding duplicate characters in a string is a common string manipulation problem. We can use a hash table to efficiently track the occurrence of each character. We iterate through the string, and for each character we check if it's already in the hash table. If it is, we've found a duplicate. If not, we add the character to the hash table. This approach allows us to identify duplicates in a single pass through the string. We'll illustrate this with a Java code example using a hash map. A bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. The algorithm gets its name from the way smaller elements bubble to the top of the list. We'll implement bubble sort using nested loops. The outer loop iterates through the unsorted portion of the array. The inner loop compares adjacent elements and swaps them if they are in the wrong order. We'll visualize the sorting process with an example. Binary search is an efficient algorithm for finding a target value within a sorted array. It works by repeatedly dividing the search interval in half. At each step, we compare the target value with the middle element of the array. If the target value matches the middle element, we've found our target. If the target value is less than the middle element, we continue the search on the left half of the array. Otherwise, we search on the right half. This process continues until we find the target value or the search interval becomes empty. Two strings are anagrams if they contain the same characters, but the order of the characters doesn't matter. For example, listen and silent are anagrams. To check if two strings are anagrams, we can first check if they have the same length. If they don't have the same length, they cannot be anagrams. If they have the same length, we can sort both strings alphabetically. If the sorted strings are equal, then the original strings are anagrams. We'll demonstrate this with a Java code example. Checking for balanced parentheses is a classic problem often solved using a stack data structure. We need to ensure that every opening parenthesis has a corresponding closing parenthesis in the correct order. We'll iterate through the string, character by character. If we encounter an opening parenthesis, we push it onto the stack. If we encounter a closing parenthesis, we check if the stack is empty or if the top element of the stack is not the corresponding opening parenthesis. If either of these conditions is true, the parentheses are not balanced. Otherwise, we pop the opening parenthesis from the stack. Let's see a Java code example to make this clear. Counting the occurrences of a specific character in a string is a straightforward task. We can iterate through the string, and for each character, we check if it matches the target character. If the character matches, we increment a counter variable. After iterating through the entire string, the counter will hold the total number of occurrences of the target character. We can implement this logic using a simple loop in Java. Let's look at a code example. Merging two sorted arrays into a single sorted array is a common problem in programming. We can efficiently merge the arrays using a two-pointer approach. We'll have one pointer for each input array and another pointer for the merged array. We'll compare the elements pointed to by the input array pointers and copy the smaller element to the merged array. We'll move the corresponding pointer in the input array from which we copied the element. This process continues until we've exhausted both input arrays. We'll illustrate this algorithm with a Java code example. Finding the length of the longest substring without repeating characters is a challenging but rewarding problem. We can solve this using a sliding window approach. We maintain a sliding window over the string and use a set to keep track of the characters in the current window. We expand the window to the right, character by character. If a character is already in the set, we shrink the window from the left until we have a window with unique characters again. We keep track of the maximum window size, which represents the length of the longest substring without repeating characters. This concept will become clear with a Java code example. Converting a string to an integer is a fundamental operation in programming. We need to handle positive and negative signs, as well as potential overflow situations. We'll start by checking for an optional sign character. Then we'll iterate through the string digit by digit. For each digit, we convert it to its numeric value and multiply the current result by 10 before adding the new digit. We also need to handle overflow cases where the resulting integer is outside the range of representable values. Let's see a Java code example to understand the implementation details. Given an array containing undistinct numbers taken from 0, 1, 2, and so on up to n, we need to find the missing number. We can leverage the fact that the sum of the first n natural numbers is n times n plus 1 divided by 2. We calculate the sum of the numbers in the array and subtract it from the sum of the first natural numbers. The difference will be the missing number. This approach is efficient and avoids the need for sorting or searching. We'll demonstrate this with a Java code example. Finding the intersection of two arrays, meaning the common elements present in both arrays, is a common task. One approach is to use two sets. We add all the elements of the first array to the first set and all the elements of the second array to the second set. Then we iterate through the first set and check if each element is also present in the second set. If an element is present in both sets, we add it to the intersection set. This approach leverages the efficient lookup capabilities of sets. We'll illustrate this with a Java code example. The singleton pattern ensures that a class has only one instance and provides a global point of access to it. We can achieve this by making the constructor private and providing a static method that returns the single instance. The static method creates the instance if it doesn't exist or returns the existing instance if it does. This pattern is useful for managing resources like database connections or configuration settings. We'll demonstrate the singleton pattern implementation in Java. Finding the first non-repeated character in a string requires careful consideration of character occurrences. We can use a combination of a hash table and a queue to efficiently solve this problem. We iterate through the string and store each character and its count in the hash table. Simultaneously, we enqueue each character into the queue. Then we dequeue characters from the queue. For each dequeued character, we check its count in the hash table. If the count is 1, we've found the first non-repeated character. We'll illustrate this approach with a Java code example. Thanks for watching. We hope these core Java coding questions help you in your interviews or practice sessions. Remember to practice consistently and focus on understanding the underlying concepts. If you're preparing for interviews, consider the time and space complexity of your solutions. Clear and efficient code is always appreciated. Don't forget to like, share, and subscribe for more coding tutorials and tips.